So I'm going to finish this tutorial off writing the basic return score function. Maybe not all of that. We'll start it. Yeah, it's a big function. It's like a few hundred lines. Okay, we'll start that. Float return score. And this is what I was talking about earlier, how the AI just scores each option it wants, which was mentioned in the paper. I'm not going to reference that right now. But, yeah. Okay, so we do float t equals 0. No, that's not needed. Let me figure out what's needed. Okay. We're going to do int IA, we're going to float t equals 0. Int okay, so now we do float int I equals 0. I is less than AD dot positive costs dot size I plus plus. Okay. Now we're going to take a look at the paper quick. So tune-based scoring. So if you read the paper, which I said to do in the last video, I think I said, a major issue that that he was running into was that the AI could not tell the difference between an increase from 30 to 60 versus an increase from 60 to 90. Obviously, if you're at 30, going up to 60 may be life-saving, it may be monumental, yada, 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 yada. So to come up with this, he started using a tunated need delta scoring, which is what he refers to it as there, where he, instead of just straightly calculating the future value, he takes the current value and subtracts the future value from that. It doesn't really sound like much. On its own, this doesn't work very well from what I've seen. You need to factor in other things, but that's what we are going to be implementing, and then counting it a lot more in the next tutorial. We'll put that there, put that there. Okay. Now, okay. Int current score, int future score. Just equals 0, 0. Okay. And now we're going to say future score equals add positive costs add I return value. So the future score is what's being advertised positively in this case. And then we're going to do, actually right now we have to create a function that takes the type from our score, from our cost, and turns it into the value that we need. So I'm just going to copy this over. Feel free to copy this on your own. I would really prefer not to rewrite this. Okay. type. So our current score is retrieved from our cost, so it'll, and let's add them. So future score plus equals current score. Obviously, because future score is the delta being provided by this positive aspect of the advertisement. So it needs to be added to our current score. Yeah, we're also going to need something else. Average, just so we can get the average of these. We can say if add positive costs at I dot type equals cost types health, or add positive costs at I dot type equals cost types food. This is just because we're saying like if it's health or hunger, because they can't get over 100%, we're saying that it'll be scaled down to 100%. So we're going to do if future score is greater than 100, future score equals 100, can't be higher than 100%. Obviously, if your game can't get higher than 100%, you don't need this. But for our purposes, we would have no reason for health or hunger to get above 100%. Now we're going to do current score. Now, what I was saying before, how certain things affect you, how you need to account to know like if false advertisements will kill you. So you don't particularly need this. You can get away without this. It only produces slightly different scores, but for the time being, you're going to use it. So switch. Oh, and then when you get to multiple entities, if you don't have this, they'll all die. But when you're with one entity, it's fine. Effects at I dot type. So switching on type, and we are going to say that food and wealth are weighed based off your economic needs. So if you run out of money before you would be able to buy the food, or if you run out of money before you'd be able to complete your doctor's visit, you need to account for that. It's not like, oh, I have enough money beforehand. It's no, during this 10 iteration period, because in a large world, 10 iterations may be 30 minutes, it may be 40 minutes. Assuming maybe my money is shared, assuming maybe I need to buy things along the way to get there, what would this kill me if I bought this? Is it worth my time? So we're going to do case, costs, cost types, dollars. This is weight off food, so am I going to starve working at my job? And I'm just going to copy this. The other one because I'm a little lazy. And this is our score function that we'll be writing now. Okay, so now let's write our score function. We go over here, we're going to go to new item, and we're going to do helper functions, h, include, and we're going to take two files from here, we're going to these two, we're going to put them here, and we're going to do include helper functions. Okay. Now we're going to struct these functions. No, what is the goal? Needs functions. It's very late here. Alright, so now let's make a tune. So we do static float tune. And that'll take one input. It'll be float in, and it'll return 10 divided by n. So because it's 10, you would get a different number from subtracting a tune 60 from a tune 30, or a tune 90 from a tune 60. It just means that it isn't a constant value for increases. That the smaller your values to start with, and if the small values have the same increase as the large values, so if you go from 1000 to 1010, from 0 to 10, 0 to 10 would give you much, well, you can't do 0. If you go from 1 to 10, it would give you a bigger value from 1001 to 1010. Okay. So now we're going to do static float score. This is going to be our scoring function. We're going to do int input 1, input 1 being our current score, int input 2 being our future score, or future value. Then we're going to do int delta, int entity value, and float completion. I will explain what all of these are. Let me just do that. Okay. Now, delta, entity value, and completion, those are for time aspect. Those are what I was talking about with this over here, the hunger delta, hunger, and completion time. These are what let me just do this. Okay. Now, these will help us figure out the whole, oh, will I die before I get this? Very useful. Okay, so now let's write the score function. Let's do float temp equals a tune input float input 1 minus a tune float input 2. I'm going to then do temp times equals completion. So we are multiplying our score, the score that is provided by this. So we're multiplying that score by the factor of completion. So the longer it takes to complete. Yeah, is that what it is? As of right now, the longer it takes to complete, the higher the score gets. Obviously, we factor in other values that would lower that, but you know. Okay, now let's write our time aspect function. So we're going to do turn time aspect Math isn't getting hard yet, so I'm quite happy with this. This should be pretty easy for people to follow along. Put the score, int delta, int entity value. Okay. Now we're going to input score times equal delta, which is the input score is a time value times the score. So that's just calculating how much food we will need to complete that during that time, but it already has our whole score factored in. You could factor the score in later. I don't think it would make too much of a difference functionality wise. It would look different, that's about it. I imagine they would still live. And then we're going to do input score equals 1 minus input score divided by entity value, which means the more food it takes to complete a task or whatever we're putting in, the lower the time aspect becomes. So, like, the more, I don't know if this makes sense. The more it kills us to do something, the lower this value will get. Yeah. So we're going to return input score. And there we go. We have our score function. Negative aspects are a lot more complicated. Those are a lot more complicated. We will cover that in the next episode. Let's just finish up what we got over here. And yeah, let's copy these in because it's basically the same thing. We're just changing it around a little. Let me just current score, future score, future score. Needs function. Okay. I'll take a break. I always forget that. Never ends well. So now we have our positive scores weighed. Oh, and then we have to do this. We have to do AB average plus equals score 1. This will be useful later on when we want to do current score. Is the issue with inconsistencies. We'll always use GitHub. It's actually pretty funny. So the average score is used for like warping between values when we're looking at graphs for the negative information. The negative information is very, 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 very dependent on the positive information. In the paper, he discovers nothing whatsoever about negative stuff. Well, a little bit. Weighted, that's about it. But we're doing it in a very unconventional way, I'd say. Not unconventional. It's pretty conventional. It's there. I'll explain it later. It's like sigmoid based negatives. It's weird. Okay, so I'm just gonna have this. Let's not forget to set it to 0. Positive costs. Positive costs. Okay. So this is our output positive score. That's what we have for score so far. In the next episode, I imagine, we will implement negative scores. And yeah, that's it. So if you like the tutorial, subscribe, leave a comment, check out my Facebook page at facebook.com/projectfero. You can follow me on Twitter at twitter.com/WireZappGames, 2 P's. And you can, if you're interested in becoming a programmer here, if you want to work on some of our projects, or if you want to get access to the code early before they go up on tutorials, you can send me an email, and we're always looking for experienced C++ programmers. Thank you, and goodbye.